So let's discuss this. So we have an equation. They're telling us that, so this appears to be the quadratic formula. They're telling us that A, B, and C are greater than or equal to 0. And they're asking us to find the derivative of C with respect to T, knowing that, as you see, A, B, and C, all of them, I'm going to put a little dot underneath. All of them are functions of time, or whatever variable. T doesn't have to be time, can be anything. So in order to determine dc over dt, we have to use what we just reviewed, implicit differentiation, keeping in mind that they're all functions of t. So can anyone tell us how to differentiate this, knowing that A, B, and C are functions of t? Anyone, please. Anyone would like to try?
Is it 2a dt?
You mean dA over dt? Yes.
Okay.
Yes, absolutely. That's the correct step. Awesome. And the rest is the same. 2b dB over dt plus 2c dc over dt. Awesome. They're all the same. Of course, I'm going to simplify dividing everything, each and every term by 2. I'm asked to find dc over dt, so this is my variable. I'm going to move this term to the other side and divide everything by c, step by step. So I have A dA over dt minus B dB over dt equals C dc over dt. In order to find dc over dt, I have all this over c. So A dA over dt minus B dB over dt divided by c. Once I have this, it's all done, because now I'm given all the information to plug in. So dA over dt, this is 0.84. B is 7. dB over dt is 3. C is 24. And you can say you're not given A. No worries, because I know that A squared equals B squared plus C squared. And I'm given B, that is 7 squared or 49. And I'm given C, which is 24 squared. So I'm able to determine A. As I said, lazy people like me use their calculator. Okay, and I take the square root and I get 25. So A equals 25, because the square root of this answer, oops, I didn't mean to do that. Yep, I meant to do that, 25. Okay. So then we have everything. So we have A, which is 25, because we were given B and C. This was given, this was given, this was given, this was given. Now I carefully have to plug them in. 25 times 0.84 minus 7 times 3, everything divided by 24. But don't forget parentheses around the top. So 25 times 0.84, 25 times I just said parentheses and I didn't start with it, minus 7 times 3, close, and divide by 24. Checking now. 25.84, yes, minus 7 times 3. Well, that's 21. I should have not done, but you know what I mean. Equals 0. Is that possible? dc over dt is 0. So I'm assuming that 25 times 0.84 is 21. 21 minus 21 is 0. That's it. So the rate of change at this particular instant, this, it will not always be 0. But in this case, it is 0 for the given information. And that was a related rates problem. Any questions? Any questions? And what was the other topic you said? Let's take a look. Yes, I remember. The 6.4. 6.4 is on page 6.4 is on this page. 582. So let's share 582. Good pick. This is only with a calculator. You don't have to calculate anything. So the reason why, as I mentioned, this section is here is because we're talking about minimizing the error. And everything that has to do with max min is in calculus. There is no need for the exponential regression. We have other types of regressions. We are only looking at the linear regression. So would you like to choose a linear regression situation? Anyone would like to pick? Anyone would like to pick a problem? Is anyone with me?
15.
Okay, thank you. Thank you. So predicting the world record in high jump. Wonderful. I love it. So the number of years since 1912. So that was 15. So x equals 0 is 1912. Okay, fine. So we have x, which is 0, 44, 61, 77, and 81 years later. And the record was the y variable, of course, which is 78, 84.5, 90.5, 96.0, and 96.5. Okay. All we need to do is just put the information in the graphing calculator, go to stats, edit. This video was recorded. I mean, the steps were recorded and the video was posted. So please watch those. Okay, so list L1 has to be, and both have to be in the exact order you see them given to you. Don't change it, and by any means you cannot make any changes because these are ordered pairs. 77 and 81, and the y variable 78, 84.5, 90.5, 96, and 96.5. Now you can say you don't have to do this, but I like to present this to you. How do I know that this is linear? Well, we go to stat plots. We turn it on. We use this one, which is the scatter plot. You can use any symbol, any color you like on some calculators. Not all of them have this. But remember, when you select the viewing window has to have anywhere between 0 and 81. So 0 and let's say 85 with a scale of 10. And y minimum, I'm going to say 60. Y maximum, 100 with a scale of 10. Why did I choose those min and max because I'm looking at the data. The data for X is between 0 and 81, and the data for Y is between 78 and 96. So when I graph, I will see something like this, sort of a line. So that's why we select stats, calculations, number 4, linear regression, and then list L1. And then, of course, I want the calculator to save this equation that we're going to get in list L1 and calculate. And here it is. A is the slope and B is the y-intercept. This is a line. So then y equals 0.2350x plus 76.7378. Now, if the problem is also asking us to use the regression line to predict the world record in the high jump in 2020 and 2050. Okay, so what does that mean is when I go to second and table, well, let's do this first. Go to y equals c. The function is already in there. Oh, I need to erase this because it's from a different class. So the equation is already there. Very helpful to save it. And 2020, by comparison to, or subtract 1912 from 2020. So you can just do the math or let the calculator do the math. You will calculate, it will enter 108. And the other one is 2050 minus 1912. Okay? So assuming, again, assuming that the trend continues, we do not know. So y equals 102.12, and then y equals 109.17. And the measurement unit was, of course, inches. So that's a typical situation. So there was something else in the chat for me. Oh, okay. Sorry. So this is a typical situation in which calculus is involved in determining these coefficients to make, one more thing I wanted to show you, because now after you plot the points, the scatter plot, and you go to the graph, you are going to see the calculator will already has the stat plot from the beginning, the scatter plot, and also it graphs the line. And as you see, this is the line of the least amount of squared errors. That's why it's called the least regression line, the line of best fit. Good. Very good. Very good questions. Good topics. Anything else you would like to go back to? Anyone? Any topics that you want to review? Also, please remember we had reviews, complete the entire class for test 1, test 2, and test 3. I would definitely watch those again. The notes are posted, the videos are posted. Good. Next topic. What are we doing next? Anyone, please? Michael, did you find something else, or did you have something else in mind? Anyone, please? Any other topics?